All right, guys, so here's an example problem where we have to integrate. It does take a lot of work, but it's actually pretty simple. The idea is pretty simple. So if we look at it, we have that a particle moves along a line. Its position is s of t, its velocity is v of t, and its acceleration, they actually give us the function a of t equals 1. Given us two different initial conditions, that v of 3 is negative 3. We'll call that initial condition 1, and then s of 2 is negative 10. That's initial condition number 2. And let me explain a little bit more. It's just simple. You have your velocity, you have your position, you have your velocity, and you have your acceleration. So in order to go from position to velocity, you have to take the derivative, and velocity acceleration, you take the derivative. Well, here we're going to start with acceleration, so we got to do the antiderivative to go backwards, and that's where we'll use initial condition 1. And that's because they're giving us, velocity is negative 3. And then initial condition 2 comes in right here because we're going to have to do the antiderivative again because they want position in the end of all this. And they actually want position at 4. So that there we would use our initial condition number 2 there. So let's go ahead and get into this. So we're starting with acceleration function. So to get our velocity, we're going to do the antiderivative of acceleration, which is just 1. The function 1, kind of interesting. So that antiderivative is t plus c. So that's what our velocity function is. Now this is where we're going to stop and use our initial condition 1. So our initial condition 1 is that v of 3 equals negative 3. Let me just double check that real quick. So v of 3 equals negative 3. So I'm going to go ahead and substitute that in. So v of 3 equals negative 3 plus c. And so negative 3, oops, no, got that wrong. V of 3, I'm just plugging in a 3 into the t. See, I'm making a mistake there. And so that equals 3 plus c. So c is negative 6. And so I'm going to take that negative 6 and substitute that in there. So our velocity function is going to be t minus 6. So now to get our position, s of t, we're going to go ahead and do the antiderivative of velocity. So we're going to do the antiderivative of t minus 6, which will get us t squared over 2 minus 6t plus c. So that's our position function. So now's the time that we're going to use our initial condition number 2, which was s of 2 equals negative 10. So s of 2 equals 2 squared over 2 minus 6 times 2 plus c. And then negative 10 equals 4 over 2 is 2 minus 12 plus c. Negative 10 equals negative 10 plus c. And then add the 10 to the other side. And we will get 0. So c is 0 in this case. So s of t equals, we're going to go ahead and just substitute that 0 in right there, equals t squared over 2 minus 6t. So does that answer the question? Not quite yet, because they're asking for s of 4. So we're going to go ahead and do s of 4 now. So s of 4 equals 4 squared over 2 minus 6 times 4. So that's 16 over 2 is 8 minus 24. And 8 minus 24 is negative 16. And that's what s of 4 equals, and that answers that question. So I do want to talk about an alternate method. It actually takes place right here. Let me see, it takes place at this spot here instead. So we have an alternate method. And my recommendation is, given a graph, to do this method. So this method would be the integral of velocity from a to b, if you remember, is going to be s of b minus s of a. I know earlier I was using x of b minus x of a. Same thing. We interchanged those. So velocity function here would be t minus 6. And if you notice our initial condition starts with 2 and we're ending with 4. And it could be backwards, but point is I'm going to go ahead and use A as 2 and B is 4. And why do that? Well, we're trying to find S of 4, and we're going to give an S of 2. I wouldn't use any other numbers because it's going to fit right into this formula, because that's going to equal S of 4, which is what we need to find, minus S of 2, which is what we're given. And that's why we're going to use 2 and 4, because we're trying to find S of 4, and we're given S of 2. So anyways, you would have to integrate this. I'm going to use an integral calculator, but if you guys remember the definite integral, you do the t squared over 2 minus 6t from 2 to 4, and then you'd have to plug it in and subtract and all that and find that out. It's really more work that way if you're doing it the algebraic method. But if you're given a graph and the only thing you can do is find the area under the curve to find your definite integral, then this is the method you have to use. So that's why I want to talk about this. So anyways, the integral calculator will outpop a negative 6 for this definite integral there. So that's what we would get for that. I'm going to use a different color. I was using light blue earlier. So this would be negative 6, that integral there. Still don't like that. Let me just circle that. This integral here would equal negative 6. And then S of 4 is what we're trying to find. And S of 2 we're given as negative 10. So negative 6 equals S of 4 plus 10. Subtract the 10 and you get the S of 4 is negative 16. So notice you still get the same answer using this method. It's the same answer, just this one works better if you were to be given a graph. So if you're given a graph, then you would have to do that method, because in order to evaluate this integral, you'd be doing it by using the area under